I'm a student of Research, and today my presentation is for the PicoRio on Google Skywater PDK. I'm also not very familiar with semiconductor craft, so just sharing with you. When we want to manufacturing an ASIC, there are three components needed: RTL design, EDA tools, and PDK data. And of course, it's not very precise because if you are analog designer, then we will replace the RTL design by MOSFET and some physics device. And PDK is actually the symbol of the manufacturing flow in the foundry. And you can see in this picture, the PDK describes some physics arguments of semiconductor craft. And our design is limited by these physical rules. In Skywater 130, we can use 5 types of metal for connection. And the smallest size is 130 nanometer. I want to use C++ programming as a reference. When we are programming C++ program, we have a compiler and assembler. So with these tools, we can compare our design source C++ files to the assembler, then to the binary. Then our CPU can run our program. As in the ASIC flow. In ASIC flow, we have very Verilog VHDL system Verilog as a programming language. And then we use the synthesize tools to synthesize our design to get the values. At last, we will use the ASIC flow, use the ASIC tools to implement our design and get the GDF file. GDF file is actually describes the mask in the craft. And there are also some simulation tools which is very similar to the GDB in the C# programming, and they can help us to debug and find the error of our design. So, for example, if we have some Verilog files as RTL design, we will synthesize them in the and get netlist for the first. With the ASIC tools, we will compile our netlist and generate the GDS file. Of course, it's not that simple. In the progress, we also need to do DRC, LVS, compile the clock tree, and divide the power domain, and so on. Whatever, we got the GDS file at last. And we will provide it to the foundry, and they will help us to manufacturing the ASIC. So EDA tools is really important in ASIC flow. It helps us to verify, evaluate, and implement our ASIC design. Another thing is in ASIC tools, when we are implement our design using ASIC tools, in this process, EDA tools also need PDK to provide some information and some basic design cell to some basic stencil model, SRAM and IO and some other libraries. So this slide shows some commercial EDA vendors and silicon foundries. This company can get a huge number of profit area. So EDA tools and PDK are absolutely sensitive further. Now we go back to Skywater. Skywater is open PDK designed by Google, along with some open EDA tools like OpenRoad and OpenLAN. These tools can help us to finish our S flow in our data. To develop this open source EDA and PDK, Google also built an open foundry in Europe to support its Skywater PDK. And now 130 nanometer is available. Skywater have a patch 2.0 license, so everyone can access it on GitHub and download. Another good news is that Google will provide free typeout in 2021. So it's a really good chance for our students to study as students. If you are interested in this plan, you can access Skywater website for details. In this slide, there are some example projects on Sky 130. This graph shows on screen are the layout of some DLNs. You can see the basic style like D flip-flop and the basic SRAM cell. Someone also implements ARMv4 core using the Skywater 130. So, Skywater 130 is not a very advanced technology, but we can still use it to do something useful and get not bad performance. Today, we will announce a new project about implementing PicoRio on Skywater PDK. And it will be a full open source version without details from front end to back end open. It's impossible to get our DLN open if we don't have Skywater PDK, because the PDK is really a sensitive thing for the foundry in the past. So this year we will re-implement the PicoRio by the open source EDA like OpenLAN, OpenRoad. We will compile our SRAM cell using the OpenRAM, and then type out it in the summer. We will also want to implement some new chiplet ideas and open source analog I/O, such as we can tighten our chip and with Intel FPGA and do some interesting application on it. This is our schedules. We hope we can type out our full open source PicoRio in summer. That's all. Thank you.
Now then, it's the last talk before topic break, and after topic break, we have another talk about that's one of, and another one is the open source industry. So I believe we can everyone can sit down and